Hi, so welcome to my YouTube channel. So today we will learn about the largest BST, that is the POTD of GFG. The problems is that same thing, like the problem is related to bandits or trees. So in that you are given a bandit tree. Your task is to find the size of the largest subtree within this bandit tree that also satisfies the properties of a bandit subtree. BST. The size of a subtree is defined as the number of nodes it contains. Right? A subtree of the bandit tree is considered as BST if for every node that subtree that left child is to and the left child is the less than and the right child is greater than without any duplicate values in the subtree, right? So the problem says that we can use here to the post order traversal. Why we use post order traversal? For every node, what it says the post order traversal? Post order, which means first come here, then here, then here. Like this is the post order, which means firstly, like in that value, for every node, return four things about its subtree. What the things? The first thing is BST size, mean value, max value, right? The main idea, a subtree rotate at node is BST only if left subtree is BST, left subtree is BST which means our uh, that means our node value is left smaller than, right is greater than. That is our BST. That is the BST. You know about the BST? BST is always what is the left side a smaller than root and root and right side bigger than root, right? That is our BST. So the main idea is left subtree is BST, right subtree is BST. Left dot max value, there is a concept like left max value, right? Node to data, right? Mean value, right? This is if true, this यदि ये correct होता है, if that is true, which means this subtree is BST, right? Size is equal to left size plus right side plus 1. If false, this subtree is not BST. If it is not satisfied this conditions, which means that is not the BST, right? Answer from this side is maximum BST size found in the left right, and we have to find the maximum BST size found in left or right subtree. And in that we just says that we have to pass the order of n time because each node is proceed once, right? So for daily we just write the code, right? So the first thing is we just have to return the struct info, right? Like bool is BST and int size and int mean value, int max value, correct? Now in the last thing, what is says the root? Int answer is equal to 0 and solve रूट का डेटा दे दो, रूट दे दो एंड आंसर दे दो, टेक एंड रिटर्न आंसर. Now we don't have to anything here, I just have to go and write the info solve. I have to take from the info, right? Info solve, it is not a solve, this is solve, right? Node root and int answer, right? Now if root is equal to, that is the best case in all. If you have to solve any problem in tree, then you must use this test case, that in this edge case. Then return true, 0, int max, int min, right? Now info left is equal to solve root left answer, and info right is equal to solve root right answer. Info current dot size is equal to left dot size plus right dot size plus 1, right? Now check BST conditions. If left dot is BST and right dot is BST and root data and left dot Maxwell and root data to right dot meanwhile, right? So if this is this much here, then current dot is BST. If current is BST is true and current is mean value is equal to minimum of root data dot left dot mean value, current dot max value is equal to max of root data and right dot max value, right? Answer is equal to max of answer to current dot size, right? And then else current is BST is equal to false, then current dot mean value is equal to int min and current dot max value is equal to int max, right? And at the end return current. See, it will pass or not? Yes, it will pass the test case. It will that means yeah, so it will pass all the test cases, and in that the time complexity is order of n and the space is order of h for the recursion stack, where is h is the height of the tree, right? So that is time complexity is order of n and space complexity is order of H. Yeah. So thank you for staying till the end, and please like and subscribe my channel. Thank you so much.